Question 19 from Section 1 of the 2019 National 5 Physics Examination. Which of the following diagrams shows the diffraction of water waves as they pass between two walls? Well, let's do this simulation experiment by going over to the PHET site, and the only difference is our barriers or walls are turned on the side. So let's start the waves with a wave generator, and you can see the waves approaching the gap between the two walls. And first of all, you notice that the wavelength of the waves is much, in fact, smaller than the gap in the two walls. The gap is much bigger than the wavelength. Now, another thing I want you to notice is that when the waves pass through, they're almost straight, except for the edges, which show a little bit sign of diffraction. So they pass through straight, and at the edges, there's a bending of the waves, which is a diffraction. Another thing to notice is that the wavelength of the approaching waves is exactly the same as the wavelength of the waves that pass through the barrier. So once again, there we go. The waves pass through, almost straight, showing signs of bending or diffraction at the edges, and the wavelength on the left side of the barrier is exactly equal to the wavelength on the other side of the barrier. So let's go back to our question and see what we can get then. Well, obviously, if we look at the questions, letter A is wrong because it's showing no signs of diffraction. For B, you can see the waves go through and the wavelength is the same on both sides, but not all the wave bends, so that one is wrong. Part C is wrong because the wavelength as it passes through the barrier, passes through the walls, the gap in the walls has got a much smaller wavelength, so that one is wrong as well. Now for part D, you can see the wavelength of the waves as they approach the gap between the two walls is exactly the same as the wavelength after the walls, and most of the wave passes straight through, and you're seeing signs of diffraction at either end of the emergent wave. So that one is a good candidate. Let's look at our final response. We have the waves passing through the wall, they're going flat, big bit of diffraction here, but the big giveaway is that the wavelength is bigger at the other side of the gap between the walls, so that one is wrong. So our answer for question 19 is D. Question 20 from section 1 of the 2019 National 5 Physics Examination. A ray of red light passes through a glass block as shown. Which row in the table shows the angle of incidence and the corresponding angle of refraction at point X? Well, we know that the incident angle is always between the normal and the incident ray. So here we have the incident ray here, and we're looking for the angle between the normal, that's the normal, and the incident ray. So this angle in here is what we call the angle of incidence. If we go and look at the angle of refraction, the refracted angle is always between the normal and the refracted ray again. So we're looking for the refracted ray and the normal. We're looking for this angle in here. So that's our two angles, but you can see we're not given a value of them. But we can easily work that out, because if the normal and the side of the glass block are like that, then it's right angles. The normal always makes a right angle to the surface of the glass block where the ray is meeting it. So this angle in here will be 55 degrees from 90, which leaves it to be 35 degrees. So that's the incident angle. So we have a choice between that one and the other one. Now let's look at the refracted angle. It's between the ray leaving and the normal. We know that angle in here is 90 degrees. The normal makes an angle of 90 degrees to the surface of the glass block. So this angle in here must be 60 degrees to make up the 90. So we've got that response there. So our answer to 20 is 20A. Question 21 from section 1 of the 2019 National 5 Physics Examination. Which row in the table shows the paths taken by alpha particles and gamma radiation as they pass through a uniform electric field between two metal plates? And you're given your 5 options. Quick recap, what is an alpha particle? An alpha particle is really the nucleus of a helium atom. It has 2 protons and 2 neutrons. The 2 protons are positively charged, therefore the alpha particle has an overall charge of +2. A gamma ray, on the other hand, has no charge. It's an electromagnetic wave. So for a gamma ray, it will not be affected by the electric field. So we're looking for the following possibilities. Gamma ray, not affected, so it could be that one, and it could be that one. Now for the alpha particle, it will be affected by the electric field and it will be attracted to the negative plate. So we're looking for the path to bend towards the negative plate. This one's out, this one is in, and so is this one. But as you can see, it's got to be answer B, because the gamma ray passes through the electric field plates without deviation, and the alpha particle is pulled down towards the negative plate. So our answer for 21 is B.